I had to record this in 2 parts because it was too long. Example 3 I think is pretty easy. You just have to identify if it's a growth or if it's a decay. So let's see if it's a growth or a decay. So look at this equation. Remember, for growth we're always adding to 1, and then for decay we're going to subtract from 1. So when we look at this, we notice that my rate is really 1 plus 0.07, 7 hundredths. So that means my rate is 7%. And we convert it. Okay, and for B, if you look at my rate here, this rate is less than 1. So 1 minus R is going to equal 0.98. And then when we solve it, we find out that the rate is 0.02, which means it is a decay of 2%. So this last section is pretty tricky, so you want to pay really close attention, and you got to make sure that you got your calculator available. Okay, so we're going to look at each of these equations and just determine if they are growth or decay, and we have to rewrite them so that the t is not in this rational exponent type of format. So let's start with A. Okay, so y equals 100 times 0.96, and if you remember your rules for exponents, t over 4, so I'll rewrite it here on the side. T over 4 is really 1t over 4. So that means that this is really 1/4 times t. So we're going to pull that apart, and we're going to say that this is 0.96 to the 1/4 to the power of t. That's super tricky. Okay, you have to know how to take apart your fractions here. So now we're going to take our calculator and we're going to calculate this. So I'll do it here. So parentheses, 0.96, close parentheses. Okay, remember the caret? So we're going to do the caret, and we have to do parentheses again because it's rational. So we're going to put 1 divided by 4, close parentheses, and then we're going to press enter, and that comes out to be 0.99. So y equals 100 times 0.99 to the t. And that is now your new function. And since you can see your rate here is less than 1, you can definitely say that it is a decay. Okay, so now let's look at B. This is tricky. Alright, we have this function, and we remember our exponential rules. Move it over a little bit. So remember that when you subtract your exponents, it's really division. So let's rewrite this. F of t equals 1.1 to the t divided by 1.1 cubed. I know that's super tricky. You have to remember that when you subtract the exponents, it's really division. So now we're going to calculate this denominator here. Clear that. Parentheses, 1.1, close parentheses, caret to the 3rd power equals 1.331. Now remember, again, you have to learn to pull this apart. So this is really 1 over, I'll put this, I calculated this already, 1.331, right, times, I know it's tricky, 1.1 to the t up here in the numerator. Okay, let me bring it down here so there's more space. Sorry about squeezing that. So what this looks like is, let's just do the denominator. So the denominator is 1.331. The numerator is still 1.1 to the t, but there's a 1 here. So to make sure that this is no longer a fraction, I'm going to divide this here. So I'm going to put 1 divided by 1.331 equals, aha, that 0.75 turns out to be A, 1.1 to the t, and 1.1 turns out to be my rate, and since it is greater than 1, it is definitely a growth. I know that's tough. We got to do lots of practice in class. Okay, so here's monitoring progress 6. It looks kind of scary, but it's not. We're just going to rewrite it so the formula has t as the exponent by itself. Okay, so this is going to be 3 times 1.02, and remember, I'm going to do it here on the side. When you're multiplying two exponents together, you can pull them apart to be a power of a power. So this is really 1.02 to the 10th power to the t power. Then we're going to take our calculator and clear it. I'm going to put it doesn't matter, 1.02 caret to the 10th power, and I'm going to calculate that, and that comes out to be 1.22. So I'm going to rewrite it, 3 times 1.22 to the 10th power, to the t power, and this is my new function. And I can conclude, since this is greater than 1, that this is definitely a growth. Okay, last problem, monitoring progress 7. I'm going to rewrite this function and try to determine if it is a growth or if it is a decay. So y equals, if you remember your rules of your exponents, you're allowed to add them when you multiply them. So let's do the opposite now. So that means this is going to be 0.95 to the t times 0.95 to the second power. Because when you multiply them with the same bases, you add them. Okay, so let's use a calculator again. Last one, I'm going to do this one right here. 0.95 caret to the second power. Oops, delete that. To the second power, and that is 0.9. So my new function, since that's it, is going to be y equals 0.9 times 0.95 to the t.